So just see that reset circuit in the PPT. It is there. Is it visible or is this very small one? I think. Just a minute. I think now is it visible, right?
No, sir. It is not clear.
Now is it visible? I mean, to some extent. Just see in the
Sir, I think you are visible, sir. Your copy is not.
yeah another in my name another I mean
Oh, yes, sir. Yes, sir.
user is there. Okay, so there you can just pin the video. Okay,
Yes, sir. Yes, sir.
yeah. So look at the bottom side. Okay, look at the bottom figure, that is figure 4.3b. Okay, and table 4.1 you need not to see through, just 4.3b. So look at my copy. This is the microcontroller side. Okay, so I am writing 8051. Okay, and here pin number 9 is there. Okay, and this is RST, that is the restart pin. Okay, is my copy is visible or I need to zoom in the camera?
Sir, visible, sir.
Okay.
No, sir. No, sir.
Okay, okay. So this pin is pin number 9. So if any positive pulse is given to this pin, then the microcontroller will be reset. Just remember that your just a minute. Yeah, so high signal is given to pin number 9, then this 8051 will be reset. Just remember where your mobile phone or your laptop is there, then what happens, there is a key of there is a lock key or the power button. So you press it and there are kind of software interface comes that there is start, shut down, and flight mode and something else. Okay, so here only this pin is given to reset this 8051. So we need to design a circuitry for the same. Okay, now how to do this? Now being simple in this figure 4.3b, we are just connecting. Just look at my copy. Just connect a resistor to the ground, and the value of the resistor is 8.2 kilo ohm. Okay, clear? Now again a capacitor will be there, and in parallel a switch will be there. Okay, and from here plus 5 volt will be given. Clear? Now this is the switch. Now what happens? Now whenever this switch is not connected, this capacitor is slowly charged. Okay, but this cannot be this follows this minimum path, because this R and C, this will not be, this is connected to the ground. Clear? Whenever we are pressing the switch, that means whenever this switch is disconnected, this SW, then the current flows through this way, but this capacitor only charges. Okay, so at this point there is 0 volts. Okay, so that is unconnected kind of thing. But whenever this switch is pressed, then this path is shorted So the current flows through this, okay? And coming on this point, the current will go in which way? This way or this way? Anybody?
Yeah, sir, RST pin.
Yes, because it is the shortest. I mean, the shortest resistance, the minimum resistance path. The current is following the minimum resistance path. So this minimum resistance path is nothing but this RST pin. So this 5 volt will come through this way and to this RST pin. Okay, so this RST pin is set to 1. Now what happens? Now we have discussed that there are some, there are microprocessors or your phone, your mobile phone or your laptop, whenever you start this laptop, mobile or desktop, then what happens? At first the user interface actually enables. That means the operating system is operating system is a user defined program that is used to interface between the hardware and the software. Software means the user. So the CPU needs to understand that in the circuitry, in the total circuitry, there are memory, there are IO devices, there are printers, mouse, keyboard, and other peripheral things. So whenever the restart key is pressed in case of 8051 microcontroller, look at this table 4.1. The content of those registers, that is program counter, is set to 0000H. Accumulator is set to 0000H. So every registers you can find that is set reset to 00 except stack pointer. The stack pointer value is set to 0007H. Okay. Now remember what is 0007H? Can you remember what is the address of, in the address of 07H, what is there in the microcontroller 8051? Just in the earlier class we have discussed.
Bank register.
Right, very good. So this,
Bank.
yeah. So 07 is the R7 register of bank 0. Now the operation of stack is like that. In the 8085 microprocessor and 8086 microprocessor, you have already learned that the characteristic of this stack pointer is like first increment the stack pointer by 1 and store the data. Like, right? So in case of storing the before storing the stack data into the stack pointer is incremented by 1. Okay, so the increment, that means the stack pointer value will be 08. Clear? So this 0 means the bank 1 R0 register. I'm just going to this, just a minute. Just look into this. So this 07 is the address of R7 register in the bank 0. Whenever any stack operation, any instruction that is executed and that use the stack pointer, then what happens? The stack pointer is incremented by 1. That means 07 plus 1, 08. 08 means this R0 register of bank 1. So by default, we have discussed that by default, bank 0 is selected. If we are not writing any program or initialization of any other banks, by selecting those, just a minute, by selecting these bits, okay, if you are not putting anything in RS0 and RS1, by default the microcontroller will understand that the microcontroller is set to 00, this bank 0. Okay, so obviously after that, if we require the register of any banks, so by default R0, R7, R0 to R7 of bank 0 will be selected. Clear? Any questions on this?
Sir, after 07, what will be the register that will be used after 07? You
That
said
is
it
all
will be incremented by 1, sir.
right. But the thing is, whenever we are writing a program that uses multiple banks, okay, we need to initialize it. I mean, before using it every time, okay. But for the small program, where there is number of registers are not needed, if we do not put this do not initialize this rs0 and rs1, then what happens? One or two numbers of lines in the program will be decreased, so the program length will be decreased. That is the thing. I mean, if you are writing a long program, adding 2 3 lines will not issue much. Okay, any other questions?
Sir, that circuit part, why the capacitor is not discharging, sir? After a certain time, it should be discharged. No?
Yes, but the thing is, there is polarized capacitor. Okay, so I forgot to just mention. So after a time, I mean, this is the DC voltage. So you know that this DC voltage is, blocked by this capacitor, right? I mean,
Yes, sir. Yes, sir.
yes. So this is the 5-volt DC because we are connecting a battery. Clear? We cannot connect
Okay, sir. Okay.
Yes, sir.
AC things with this 8051 microcontroller. So it is blocking this, and if we are putting the switch on, then it will follow the shortest path. Clear?
Yes, sir.
Yes, sir.
Okay. Any other questions?
Sir, one more question, sir.
Yeah.
Sir, initially the switch is not connected. The switch is off.
Yes.
Then you said that the 5-volt source is slowly charging the capacitor, and the capacitor is following the shortest path through the resistance and going towards the ground. So in that case, the
No. Just a minute. Just a
DC
minute. Let me correct
voltage.
you. I mean, if I told that 8.2 kilo ohm is there, it is not following the ground.
Yes, sir.
Okay, I told you wrong. But the thing is, what you have
Okay,
pointed out that okay, like, complete your question.
sir, that is my question, sir.
Okay. So apart from this, apart from this 8.2K register, 8.2K register is having another, another operation. I'll come to that. But before this, the AC components, there is very small AC components that is included in the DC. Clear? So in every cases, this AC components are included in the DC one. Okay, just like the reverse one, that AC components are having some DC components within. But whenever we are using some power sources other than battery, okay, we can use power adapter just like our mobile phone charger. If we connect those power supplies with this battery, in place of this battery, then some small signal AC components will charge this AC. Charge this capacitor, but the charge is not that much that will discharge through this RST pin. Okay, so whenever you will come back to college and do your laboratory, I'll show you that there are some, if we put some multimeters in pin number 9, when the switch is not connected, then you will find some kind of, a small amount of voltage. Okay, so still it is a DC one, but a very small amount of AC components are present in the DC, and that is used to, that charges the capacitor. Now, why this capacitor is given? The simple thing is, if the capacitor was not there, simple thing is there. Suppose the switch is there, so maybe it is done. Some over voltage can be going to pin number 9. So to protect this, an 8.2K resistor that is used for the high impedance section, so that if some, the small amount of current must flow through the shortest path, not by the 8.2K resistor. Okay. So any other questions?
Understood, sir.
Okay. So just I'm just going. So in the internal area, internal RAM area, 00 to 1F. Okay. So 00 to 1F, that is register banks. Okay. Now next is 20 to 2F. Okay. We'll come to that. And then 30 to FF. Okay. So before going to FF, it is again divided into two parts. We'll be doing this. That is, first is 7F. Okay. So this, what is this 20 to 2F? That is nothing but bit addressable area. Just you can look into the PPT also, that there are starting from 20, it is going up to 2F. Clear? So just like this 20 is the byte address and the bit address is like this. Okay. So inside this 20 byte address, 20 hex byte address, there are 00, 01, 02, 03, 04, 05 like this. So 8 bits are there. Now to understand it better. Okay. So if we say that the bit address is 43. Okay. Now, what is the significance? Now just look into this, how to, just a minute. Now 43 is here. Where is the pin? There is a network issue. Yeah, so there was a small network issue. Okay, so I'm going back. So we are discussing that this is the 43H. Okay, so we have asked that if the bit address is 43, then what is the byte address and which bit particularly? So we need to remember this chart, and we need to memorize that this is to be done, and the byte address is 28, and bit is D4 bit, D3 bit, that is the fourth bit. So it is difficult to remind. Okay? I mean remember, and recall them is very much difficult. So there are some easy things that are present to find out the byte address and the bit position actually. Okay, so now what is the use of this? What is the use of this bit addressable area? Suppose there is a carry generated in the PSW register. Okay, so what happens? This carry needs to be stored into a position that includes, I mean that needs a single bit, because carry flag is 0 or 1. Okay, so a single bit. So where to store? Do we use an 8-bit register to store 1 bit of data? No, we can use this space to store this particular bit. Clear? This is the use of this particular area. So carry flag may be stored, the status of auxiliary carry flag may be stored, the status of parity flag may be stored, overflow flag may be stored. Clear? So these are some I mean operation that can be done by using this internal RAM. I mean this portion of the internal RAM that is called as a bit addressable area. Okay. Okay. So now we are coming to how to find out this. Okay. Now just this is the total internal RAM structure. Okay, that has been already discussed in the copy. There is again general purpose RAM or GPR, that is 3027F, and the 00 to 1F, you can see in the figure, 00 to 1F, that is used for, sorry, that is used for the selection of the bank registers are there from 20 to 2F
Bank register.
and 330 to 7F. What? General.
Scratch pad area. General purpose scratch pad area.
purpose.
Yes. So general purpose RAM will be going to, that is the way, another important, very important thing in your 8051 microcontroller. Okay. So just see into, to this program. Okay. Now what is happening? Now, how to select the PSW bits? Just we have, read that or learned that these RS1 and RS0 bits can be set or reset by the user or by the program itself. So in the set bit, just first thing, you don't know the instructions, will be going to the instructions too, that what is going on. That set bit, that instruction means a particular single bit will be set to 1. Okay, clear? So this ACTB, that is set B, that means set bit. Set means 1, reset means 0, set means 1, just like this. So set B, that means particularly this PSW4 bit is set to 1. Okay, so whenever particular PSW4 bit is 1 and we are not mentioning anything else, then obviously PSW3 will be 0 by default. If you are not mentioning anything, that means this PSW3 and PSW4 is both are 0. If you are mentioning set bit PSW4, that means PSW4 is 1 and PSW3 is PSW3 is 0. Okay.
0.
Yes. So
0.
this portion, this bank 2 will be selected. Okay. This bank 2 will be selected. So bank 2, that means this, just look into this. So in bank 2, we are going to this bank 2. Okay. So bank 2 is selected. So if we are using this R0 register, R3 register, R5, R7, those registers, that means the address of particular register will be from 10 to 17. Clear? Now, again, coming back to the program. So here you can see that R0 hash 99H. So this move R0 hash 99H, that means the immediate data, that is 99 hex, that is the immediate data that has been moved to R0 register. Clear? Now load R0 with the value of 99H. Okay. Now the question is, state the contents of the RAM locations after the following program. Clear? So again, this whenever this PSW4 is selected, then you know that bank 2 is selected. So just you need to find out the address of the bank 2, all the registers. So bank 2, that means starting from 10, it will go up to 17H. Okay. So the R0 register, the address of the R0 register will be 10H. Address of the R1 register will be address of this R1 register will be 11. Yes. Then 12, 13, 14 and going on up to 17. So this R0 means 10 memory location. This is the 10. R1 means 11. You can see 11. So like this way it is going through. This 10 hex is having the value of 99H, and lastly move R5, that means 15H, that is having the value of 12H. Is the program is clear to all of you, or any other questions?
Clear, sir.
Okay, so we are coming to the special function registers. Okay, so just a minute. Just do this now. Okay, done everyone?
Yes, sir.
Okay, so I'm stopping this. Yeah, so this is up to today, and before Puja vacation, tomorrow will be the last class of this particular subject, and after Lakshmi Puja, we'll get back to you, and probably you people know that from 9 to 11 there will be an internal examination. So in the last week, I mean last week means up to probably, just let me see. Yeah, so 7th is the Saturday. So up to 6th or 7th, with respect to the subject teachers, they will be giving your all the syllabus, what is to be included in the internal examination. Okay. So thank you. Thank to all of you.
Thank you, sir.
Thank you, sir.
Thank you.